Hello everyone. My board is very small, so explaining by writing in the notebook. This is the summary of all three topics: alcohols, phenols, and ethers. So I have sent a photo of each summary. In short, I will explain what does it include. This is alcohol preparation of alcohol. So it is prepared by 1, 2, 3, 4, 5 different methods. First method is by using aqueous KOH or aqueous NaOH, or by using moist silver oxide. Alkyl halide reacts with aqueous KOH or NaOH or Ag2O, and we get ROH. Second method is by using alkene. Alkene reacts with cold concentrated H2SO4. We get intermediate as alkyl hydrogen sulfate, which is boiled with water, and we get alcohol. Here I mentioned that OH goes to middle carbon. Middle carbon gets OH. Means addition is according to Markovnikov's rule. Means suppose if I give you propene, then by this method propene is converted into isopropyl alcohol. And this is another method, hydroboration oxidation. By this method propene can be converted into N-propyl alcohol. Got the difference in these two reactions? Here addition is according to Markovnikov's rule, and in the second case addition is not according to Markovnikov's rule. So here propene will give isopropyl alcohol, and here propene will give N-propyl alcohol. So first step is hydroboration. B2H6 is added, and we get the trialkyl borane, which is oxidized by using H2O2 in presence of NaOH, and we get alcohol. Next method of preparation, that is by reduction of carbonyl compounds. Carbonyl includes aldehydes, ketones, acids and esters. Aldehydes and ketones are reduced by using H2 in presence of nickel catalyst, heat it, or LiLH4 hydrolysis. RCOOH can also be converted into alcohol by using LiAlH4 and hydrolysis. And third one is RCOOR dash, ester. Esters can be converted into alcohol by H2 and Ni. It is said that LiLH4 is expensive, so it is better to convert acid into ester and then reduce it by using H2. Okay, so these are three reactions. Reduction of carbonyl compounds. Primary alcohol is obtained by reduction of aldehyde. Remember this. Aldehyde is reduced to primary alcohol, ketone is reduced to secondary alcohol. RCOOH gives us RCH2OH. And the last method of preparation, that is by using Grignard's reagent. In our basic lectures also we studied this. Formaldehyde, when reacts with Grignard's reagent, formaldehyde plus Grignard's reagent, we get primary alcohol. Higher aldehyde plus Grignard's reagent, we get secondary alcohol, and ketone plus Grignard's reagent, we get tertiary alcohol. Remember these conditions. So here I will write just a moment, HCHO. So it is going to give us primary alcohol. This is going to give us secondary alcohol, and here we get tertiary alcohol. Here we get tertiary alcohol. Primary, secondary and tertiary alcohol. Is this clear? This is summary of preparation of alcohol. Second photo, that is of preparation of phenol. So very simple, easy to understand. Four methods are there for preparation of phenol. First method is Dawes process. Starting substance used here is chlorobenzene. Chlorobenzene reacts with NaOH at 623 Kelvin and 150 atmospheric pressure. We get sodium phenoxide, which is hydrolyzed, and we get phenol. Second method is by using cumene, means isopropyl benzene. It is oxidized by using cobalt naphthenate as the catalyst at 423 Kelvin. We get cumene hydroperoxide, which is heated with dilute acid, and we get byproduct as acetone, and phenol is the product found in this reaction. Next method of preparation is by using benzene sulfonic acid. As it is acid, it is treated with NaOH, so neutralization takes place acidic hydrogen is replaced by Na, and we get sodium benzene sulfonate, which is further heated with NaOH at 523 Kelvin. We get sodium phenoxide. Sodium phenoxide is treated with dilute HCl and we get phenol. And one more reaction, that is by using aniline, we call it as diazotization. I always say whenever we have to introduce any group into the benzene ring, we start with NH2 so that it can be converted into a very good living group, that is N2 plus Cl minus. So diazotization we do, and that is done with the help of HNO2. HNO2 is unstable, so it is prepared by using NaNO2 and HCl at ice cold condition. Temperature is very low, 273 Kelvin. We get benzene diazonium chloride, which is boiled with water and converted into phenol. That's all. 4 methods of preparation of phenol. Okay. After that, next point is reactions of alcohol. This is quite bigger summary, but try to understand. For this chart only I am explaining all these things. So what is it? Properties of alcohol. Properties of alcohol. Alcohol shows first test as the laboratory test. In the laboratory test, different tests are taken. In the laboratory, different tests are done to identify whether the given substance is alcohol or phenol. So first test is with litmus. So no color of any litmus is changed by alcohol. So no change in color. If it is alcohol, means blue remains blue, red remains red. But if it is phenol, then it turns blue litmus red. It means phenol is acidic in nature. Second one is action of base. With NHCO3, there is no reaction. Neither alcohol nor phenol react with base with NHCO3. With NaOH, only phenol reacts and it gives sodium phenoxide, and with Na, only alcohol reacts and it gives RONA plus H2. Second reaction is action of FeCl3, which is shown by only phenol and not alcohol. So no reaction with alcohol, and phenol gives purple, green or violet color of ferric phenoxide, C6H5O thrice Fe, ferric phenoxide. Lucas reagent, so ROH, if it is primary alcohol, then concentrated HCl, zinc chloride and heat is must, we get primary alkyl chloride. If it is secondary alcohol, then HCl and zinc chloride, heat is not required for secondary alcohol. And if it is tertiary alcohol, zinc chloride is also not required. Directly we get tertiary alkyl chloride. So these are first laboratory test. Second one is esterification reaction. In esterification reaction, alcohol and acid, they react with each other and we get ester. Instead of acid, we can use acid derivatives like anhydride and acid chloride. So reaction of alcohol with acid, carboxylic acid takes place in acidic medium, we get ester. With anhydride takes place in acidic medium, we get ester. With acid chloride, we requires pyridine, not acidic medium, because byproduct formed in this reaction is HCl, which can be neutralized by this base pyridine, and we get ester. Now one more important thing, they have shown one example of acylation reaction. This is salicylic acid is treated with anhydride and we get aspirin. So this is example of this esterification reaction. Next reaction where there is breaking of CO bond. This was the type where we broke OH bond. Here we have to break CO bond, means OH group we have to replace by some other group. Very simple reactions. Action of HX, it includes HCl, HBr, HI. So OH is replaced by X. PX3, it may be PCl3, PBr3 or PI3. We get RX plus H3PO3 is byproduct always. PCl5 gives RCl plus HCl plus POCl3. With SOCl2 we get RCl. With concentrated H2SO4 or Al2O3, and of course heat is important in both the cases. Of course heating must be there in both the cases. We get alkene as product. Okay. Next reaction is oxidation reaction. In this oxidation reaction, we can use HNO3 or KMNO4 or K2Cr2O7. These are all very strong oxidizing agent. If alcohol is primary, it is oxidized to aldehyde, and aldehyde is further oxidized to carboxylic acid with same number of carbon atoms. But if we use PCC or CrO3, then primary alcohol is converted into aldehyde and no further oxidation is possible. Very important thing. Secondary alcohol on oxidation gives ketone. Ketones are difficult to oxidize. Tertiary alcohol are oxidized to ketone through intermediate alkene. It is difficult to do oxidation of tertiary alcohol. Now heating with copper at 573 Kelvin, it is also like oxidation reaction. Primary alcohol is oxidized to aldehyde, secondary alcohol is oxidized to ketone, and tertiary alcohol is not oxidized easily. Instead of undergoing dehydrogenation like primary and secondary alcohol, it undergoes dehydration reaction. So there is formation of alkene as product. Okay, these are all properties of alcohol. Next one, reactions or properties of phenol. This is also quite bigger chart, but what is it? Very easy and simple. First reaction of phenol is halogenation, that is bromination we have done. Bromination in presence of non-polar solvent CH2 CHCl3, we get ortho and para-bromophenol. I have not shown structure here. Ortho and para-bromophenol is obtained. If polar solvent is used, bromine water, we get 2,4,6 tribromophenol. Nitration, dilute HNO3 if we use, we get ortho and para-nitrophenol. In this case, para is major, very important, remember this, para is major, okay, and due to not para, I'm sorry, ortho is major, ortho, this is the different example where ortho is major, otherwise in all other cases para is major. This is the only case where ortho is major product, okay. Then dilute HNO, then with concentrated HNO3 and concentrated H2SO4, we call it as nitrating mixture. Here we get picric acid, we call it as 2,4,6 trinitrophenol. Next one is sulfonation. Dilute H2SO4 doesn't react with phenol. There should be concentrated H2SO4. It reacts with phenol at two different temperature. One is 293 Kelvin and other is 373 Kelvin. At 293 Kelvin, or that is at room temperature, we get orthophenol sulfonic acid, and at higher temperature we get paraphenol sulfonic acid. Here we don't get mixture of these two together, or we don't get 2,4,6 tri-substituted phenol. Remember this. Next reaction is Rimmer-Tiemann reaction, that is formation of salicyl aldehyde. First we treat it with CHCl3 and NaOH. Whatever intermediate is obtained, that is treated with NaOH, and further it is hydrolyzed. Remember the intermediate state. This is just a summary. So I have shown 1, 2, 3 products in this manner. You have to write complete split up each and every intermediate if question is asked. Then Kolbe's reaction. So here also we prepare salicylic acid. It is two-step reaction. In the first step, that phenol is treated with CO2 at 398 Kelvin and 6 atmospheric pressure, and then it is hydrolyzed. Third one is oxidation of phenol. It can be done by using CrO3 or Na2Cr2O7 in dilute H2SO4, and we get benzoquinone. Next reaction is reduction by using H2 nickel at 433 Kelvin, and we get cyclohexanol. Next one, that is zinc. Action of zinc, we get benzene as product. Both are reduction reaction. Here removal of oxygen, here addition of hydrogen. That's all reaction of phenol. Okay. Now next one, that is preparation of ether. Very small topic. Preparation of ether, just two reactions are there. One is dehydration of alcohol. 2 moles of alcohol are heated with H2SO4 at 413 Kelvin. Temperature is very important. it is 413 Kelvin. If we use 443 Kelvin, then we get the product as alkene instead of ether. Then we get product as alkene instead of ether, and here we can prepare simple ether. We cannot prepare mixed ether by this method. And next one is Williamson synthesis. Here alkyl halide is treated with NaOX and we get ether. This method is used to prepare simple as well as mixed ether. Note that alkyl halide must be primary. If we use tertiary or secondary alkyl halide, we get alkene instead of ether. Instead of ether. And the last point, that is reactions of ethers. So here ether, first one is laboratory test. As ether is neutral, but it has lone pair of electrons on oxygen, so it acts as Lewis base. So when it comes in contact with H2SO4, it gives oxonium salt. So this test can be used to distinguish ether from hydrocarbons. Second one is reaction of R group. ROR means reaction involving the change in R group. So it is oxidation. When ether comes in contact with air for the long time, then we get peroxide. That oxygen is introduced between carbon and hydrogen. Example I have shown, that is peroxide of diethyl ether. Next one is reactions where there is breaking of CO bond. So it is heated with dilute H2SO4. We call it as hydrolysis. This RO bond breaks and water is added across this RO bond. So we get 2 moles of alcohol. If it is heated with PCl5, we get 2 moles of alkyl halide. If it is simple ether, then we will get same molecules of alkyl chloride. If it is mixed ether, then we will get 2 different alkyl chloride. If it is hot HX, then we get RX and ROH, and ROH is again treated with HX and we get RX. So we get 2 moles of RX in this case. I have made one video for complete mechanism of action of HX. Okay, and if starting substance, here it's not aliphatic ether, it is alkyl aryl ether. We call this as anisole. Anisole when treated with HI at higher temperature 398 Kelvin, always we get phenol. We cannot detach oxygen from benzene ring. It is very difficult to remove any group attached to benzene ring. So phenol is the product and we get CH3I. And the last point, that is reactions of anisole. So simple electrophilic substitution reaction. 3 reactions are there: bromination, nitration, and these 2 are Friedel-Crafts reaction. Everywhere we get ortho and para substituted product. Bromination is done in presence of acetic acid. We get ortho-bromoanisole, para-bromoanisole, para is major. Nitrating mixture is used. Nitration takes place. Ortho and para-nitroanisole are the product. Para is major. Friedel-Crafts alkylation done by using alkyl chloride in presence of AlCl3. We get orthomethoxytoluene, paramethoxytoluene. And Friedel-Crafts acylation is done by using acyl chloride or acetyl chloride in presence of anhydrous AlCl3, and we get the product as orthomethoxyacetophenone and paramethoxyacetophenone. Okay, this is just a summary of all the topics. Write this summary in your notebook. If you have any doubt, text me, ask me. Okay, prepare alcohol, phenol and ethers.